This is a new series, a second episode in a new series. It's called The Final Three. So just to explain what I'm doing the final three questions of all of the exam papers since June 2017. This happens to be paper 2 of June 2017. If you want to check out the other videos on my channel, you can do so at the Maths Jedi. Please leave a like and subscribe, and that would help me out a ton. And if you want to keep an eye on my channel next few days and weeks, I'll be adding all of these videos on forthwith. Right, so this is June 2017 paper 2. It's a calculator paper. This happens to be the question 21. It's quite an interesting question for a lot of reasons. It's hard to spot what you've got to do here. So I'm going to go through this one with you real quick. So it says that we've got 3 identical circles inside of a rectangle, each circle touching the outside as shown here, and the radius of each circle is 24. So there's quite a few things we need to know. They're asking you to work out the area of the rectangle. So we do need this area of the rectangle. So I'm just going to label this L for ease of use for length, and this for W, just to help me out a little bit for W. Now W is quite easy because you can see that this is here going to be 24. They told you earlier the radius is 24, just down there. And so that's 24. This also is 24 because it has to be. So that's 24 there. So sorry, make that look like a 24. And then we've got again 24 here from the side to there, and then 24 from there to there. So this is 24, 24, 24, 24. So the width is 96. I'm just going to write that down up here. So the width is 96. So you get that really quickly. The length is much harder because you can't just say it's 24, 24, 24, 24, because you can see the circles are overlapping. Now, if you look at the three points inside the circle, 3 center circle, if I join those up, what you'll have here is a triangle, and what would be handy for us to work out is the height of this particular triangle. You can assume this triangle is equilateral because of course it has to be because of the way it's been formed, and you will see that what you're trying to work out then is this height of this triangle here. Now you can see that this distance from the center to there is 24. And this distance from there to there is going to be 48 because it's 2 lots of the radius, so 24 from there to there and 24 from there to there. And so what you're looking for is the height here. So that height, using Pythagoras, is going to be, well, the height squared is going to be 48 squared, which that was the hypotenuse here, take away 24 squared. So 48 squared take away 24 squared. You can reach for a calculator at this point. So here's my calculator. So I'm going to do 48 squared, take away 24 squared, and then the calculator will give you the answer real quickly, 728. And then we've got to square root that. So h equals the square root of 1728. So again, just reaching that, I'm just going to put the square root of that, and it gives you real quick 24 root 3. So h is 24 root 3. Doesn't give me the answer just yet because I've got to work out the length. So we've got 24 from there to there, and again 24 from there to there. So 48 in total, so 24 there, 24 there, 48. 48 plus this will be the height, will be the length of my rectangle. So 48 plus 24 root 3 is the length of my rectangle. So the area then of my rectangle will be the 96 from earlier times this. So 96 times 48 plus 24 root 3. Okay, and again, calculator is really handy for this. So you can just put that straight in. So 24 root 3 plus 48. So that's this bit. And then I'm going to multiply by 96 now. And I get this answer. That's 8598.645061. The question asked earlier, in case you didn't spot it, for 3 significant figures. So I'm going to write that down to 3 significant figures. I'm going to write the whole lot just so that I can come back and check it later. But 8,600 millimeters squared, and that will be the answer there. So just to make sure that you've got everything sorted out here, everything's explained really quickly. You've got the answers to 3 significant figures, and we are done. A nice, easy 4 marks. Question 22, the second last question in this particular paper, again just to mention it's June 2017, paper 2, is a sequence question. There are 3 sequences that by and large we need to know. One sequence type is the arithmetic sequence, so that's with a common difference. The second type is a geometric sequence with a multiplier, common multiplier each time, common ratio each time. And third type is Fibonacci, so Fibonacci sequences, the first 2 terms added up makes the next one. And this is a variation on an arithmetic sequence. It's kind of variation because you can see rather than having a common difference, you've got a difference of differences. And when you have a difference of differences, that means you have a quadratic sequence. So you should be able to spot those quite easily. You should have done those a lot with your teacher if you're in the revision phase now. So you can see that we're adding up 7, 11 and 15. So the difference of differences here will be 4 and again 4 and so on. So when you've got a difference of differences, a common difference of differences, your sequence has to start with the quadratic sequence 2n squared, so half of whatever your difference of differences is. So you halve that to get this coefficient here. And then all you're going to write down is just a simple table. So I'm going to write n, so 1, 2, 3, the first, second, third term. And then I'm going to write underneath my actual sequence, so it's 4, 11, 22. So 4, 11, 22. Then I'm going to write down 2n squared. So if we go back to here, 2n squared is going to be 2. 2n squared here is going to be 8. 2n squared is going to be 18. I'm going to subtract these. So 4 take away 2 is 2. 11 take away 8 is 3. 22 take away 18 is 4. We can see this is a sequence in itself, an arithmetic sequence with a common difference of +1. The common difference in an arithmetic sequence goes in front of your nth term, and then you have to see how you get from your first term, for example. So if I did n times 1, so 1 times 1, for example, I'm going to get 1, but I need to get to 2, so I have to add 1. Let's see if that works. So 2 plus 1, does that make 3? Yes, it does. 3 plus 1, does that make 4? Yes, it does. So my sequence will be 2n squared plus n plus 1, and that will get me back to the sequence that I started with. So 2n squared plus n plus 1. Very simple, straightforward, but you've got to know your revision, you've got to know your facts, all sorts of stuff coming out of this question. Do you know about difference of differences? Do you know about quadratic sequences? Do you know about how to derive simple arithmetic formula? If you can do all those things, then this is a relatively straightforward question. And again, quite a nice batch of marks. Only 3 marks for this, but quite a nice batch of marks all the same. The last question in this particular paper was this one. This is question 23, slightly more difficult, bit meatier, requires a bit more, bit of thinking. But it's only worth 3 marks, so it's not massively mark laden. This is a circle, so we can sketch the circle. You can see the circle here. I've already got it in my mind as 2 and minus 2 and minus 2 and 2, so square root of the 4 there. So I'm thinking of my circle here. They're saying this point is a point, so I can sketch that point here. So that's 1.5, so I'm thinking it's somewhere over here. So that's my point, so 3 over 2 and root 7 over 2, it's a point on my line. Drawing a little line up there. And they're saying, find an equation tangent to L. So the tangent to L will be something like this. So a little tangent there, it's going to bring that right to the camera so you can see it. Now the first thing to do with these sorts of problems, these problems are quite common, is to find out the gradient of this line. So there's 3 steps: find out the gradient of this line, find out the gradient tangent to it, and then find out the equation of the tangent by using this point. So those 3 steps again: find out the gradient of this line, find out the gradient of the tangent to it, and then find out the equation of the tangent by using this point. If you want more guidance on that, I've done a separate video on coordinate geometry. You might find it on my channel, so just do take a look. It's about half an hour of me doing exam questions, and I think this is even one of them. So have a look, take a look at that, and you'll hopefully understand it a bit better. In terms of this question, we're going to find out the gradient of this line. So how do I find the gradient of this line? When I do change in y over change in x. So root 7 over 2 divided by 3 over 2. So again, these 2 things, that's going to be root 7 over 3. The gradient, the tangent to it, will be perpendicular. You can see it's perpendicular, and perpendicular gradients are the negative reciprocal of this. So the gradient of perpendicular so gradient tangent, say, for this one, will be minus 3 over root 7. So you flip it upside down, stick a minus in front of it, that gets you to minus 3 over root 7. Now, we now know that my formula for my tangent starts with y equals minus 3 over root 7x plus c. It'd be nice to get this into a rationalised third form, so I'm just going to rationalise the denominator real quick, so hopefully you understand where I'm getting that from. If you don't understand that, again, there's a video on surds, you might want to take a look, but minus 3 root 7 over 7 is what you get if you rationalise the denominator. Just get that root 7 out from underneath, and that's what you would get. I need to find this point here, so we're going to use this point again, this point up here or this point here. We're going to use that to find out what's going on here. So I'm going to use y as root 7 over 2, and then minus 3 root 7 over 7, lots of x, which is 3 over 2, and then that's going to be, and then that's plus c. We have to rearrange to get the c. So I'm going to collect all this together. Again, you can use a calculator to do this real quick. Calculator is really good with the surds these days. You know, you can do lots of things to help you out, but you can see hopefully where I'm getting this from. I can do these in my head, but calculators can do these just as well. And you can see you're getting minus 9 root 7 over 14. Again, nice rationalised denominator. And then again, we'd like to collect this all together on the same side. So root 7 over 2 plus 9 root 7 over 14. Again, I'd like to add those two fractions together, so I'm going to multiply this by 7 on top and bottom. So 7 root 7 over 14 plus 9 root 7 over 14. Okay, and then again, because we've got the common denominator now, we can add those two things together to get 16 root 7 over 14. That's going to be c. Okay, so that's these two things together make c. And then that's 8 over 7 root 7. So my equation will be minus 3 over root 7 x, and then plus this rationalised, so it's 8 over 7 root 7. Oh yeah, sorry, I should have put that in rationalised form, so minus 3 root 7 over 7 plus 8 root 7 over 7. And that will give you your equation of your tangent. 3 marks, quite straightforward, but again, something that tests revision, tests your ability to understand under pressure how you're doing it. So a few things to revise there. Do you know about negative reciprocal? Do you know about popping points in? Could you do these complex surd fractions relatively easily? All this stuff is all good revision, worth thinking through, worth having a go at. And again, just practicing lots and lots of questions is the way to go. That's the end of this video. So this was paper 2, 2017. Good luck for your exams in the summer. I do wish you all the best, and hopefully you'll catch me soon on some other videos. If you check out the channel every day, you'll see some of these things being uploaded in the next few days and weeks. Good luck. See you soon.